So let's proceed to the last topic of the application of your definite integral, which is work and liquid pressure. So in these topics, so probably you're going to have difficulty in absorbing um, these applications, especially in the liquid pressure topic, because this topic is introduced. I mean, it will be introduced when you will be in your third year, which is in fluid mechanics. So muna medyo difficult to absorb a topic because it's a major subject in civil engineering. So for work, probably the work may be easy to absorb because it's coming from the physics concept. So one is coming from physics, and then the other one is liquid pressure, which is a major in civil engineering. So let's try to um, explore the different topics. So let's start with work first. So work done by constant force and work done by variable force are the two types of work that we are going to discuss. So in physics, especially in high school physics, so what we did in those years is that we just solve the work with a constant force, meaning the force is not changing with respect to the distance, or meaning one variable is fixed, or I mean all variables are fixed to determine the work. So as per formula for work is equal to force times the distance. So if the force is fixed and then the distance is also fixed, so meaning we can determine the work easily through the formula. So that's why there's a work done by a constant force. So if you have a constant force, so meaning the formula will be used right away. So I just applied all the wordings in the slides so that later on when you review the recording, so you can just pause and read the terms. And again, since this topic is difficult to absorb, so that's why I try to make it as complete as possible. So let's try to observe the sorry. So let's try to observe um, the example for the constant force for work. So determine the work done in lifting a 50-pound object 4 feet. So you have a 50-pound object. So this is the weight. So usually the weight is the force already. And then 4 feet is the distance. So notice that once if you read the problem, so everything is already fixed. So there's no need to determine any variable terms such as the force or the distance. So we directly use the formula, which is work equals force times the displacement or the distance, and it will give you a 200 foot-pound work. So diretso siya, diba? If you can compare it, if you can compare this one later for the work done by variable force, so there's a difference because if we're trying to determine work done by variable force, so we'll be using integral calculus na. So if you forgot the units for work, so work is force times distance. So in English system, so you may write it as pound foot, or in this manner foot pound. It could also be foot pound because since it is just a commutative property of multiplication, so you can just reverse the terms. So it could also be pound inch. So in metric system, so I think the most popular unit for work is joules. Or if you don't want joules, so it could also be kilonewton per meter, newton per meter, newton per millimeter. So those are the different metric measurements for work units. All right, so if we try to go to work done by a variable force, so notice that there are a lot of words on your screen right now, but just try to read this one all throughout by pausing the video later. So if you have work done by a variable force, so meaning the force is changing with respect to the distance. So an example for this application for variable force is, let's say you are compressing a spring. So the amount of force that you are compressing in on 1 inch distance is different compared to the 2 to 3 inches distance, diba? So why is it different? Because probably it's because of the material, diba? Because of the spring na siya resistance, or let's say you are lifting an object upward. So if you try to bring in the component of gravity, so as you go higher, you are trying to exert more force because you are pushing against gravity. So that's why your force is becoming a variable unit. It is changing with respect to distance. Diba? So for example, I think one great example for this one is a rocket. So kana mga ipang-adto sa outer space, diba? So you need a certain amount of force. So at the first few distance, diba, on the Earth, so murag gamay pa kaya ang force kailangan sa rocket. So once murag mo go outer na siya, as it goes higher and higher, so it will take a lot of force for it to push through to the outer space, diba? So murag mo na siya ang idea for variable force. So the force is changing with respect to distance. So earlier, when you are lifting the 50 feet object, the body weight for 4 feet, so the 50 weight is not changing with 4 feet. So that's why it's a constant force. So dire in the next few problems that we're about to discuss, so the force will be changing with respect to distance. So murag mo na siya inyong econ. I think that's what the concept is all about. So the force is not constant all throughout the displacement of the body or of the object. So for the formula, so as you can see in the formula, it looks like the original formula. So work is equal to force times distance. So if I'm going to explain this in a no-brainer, so you can just make the dx as, your distance as dx. Since this one is the distance, so you can make this one as dx. Then with respect to a to b, or with the limits from a to b. And then the force, since the force is a function of your distance, so that's why the force is a function of x. So that's why it's f of x dx from a to b. So it looks like the original formula, but we are just changing it in terms of equations since the force will be dependent on the distance. Diba? So muna siya ang idea. So that's why the force is now a function of x. So ang force, mag-agad siya sa distance. That's why it's a function of x. And our x is being the distance from A to B. So as you can read here in the first line, So the object is moved from A to B, which is the x displacement. All right. So as what I mentioned earlier, so work done by a variable force can only be narrowed into a few topics. So let's say you are solving problems referring to centrifugal force, electromotive force, gravitational force, um, frictional force, so on and so forth. So I think most of the exam that will, in my experience for the past 7 years, so most likely the problems that will be coming up for work is more on Hooke's law, which is more about um, the spring problems, and also for the gravitational problems. So that's why I just introduced two topics here instead of the many topics for variable force, because I will only be focusing on the problems that will come out mostly in the exam. So first one is Hooke's law. So I think from your physics, you are pretty familiar with Hooke's law. So you need to solve the spring constant first, because again, the spring constant will give an effect on the force that you need to exert for the pushing or for the compressing and the pulling for the spring. And also for the gravitational aspect of the variable force. So most likely, so just try to ignore this one. So I just put this one here. But most likely, if you're going to determine gravitational forces, variable forces, so it will be dealing with lifting objects vertically, diba? So of course, lifting vertically siya. So mura na siya inyong i-expect for variable force. All right, so let's try to determine the work done by compressing a spring. So I already showed every solution here. So by Hooke's law, so again, we need to determine first the K, the spring constant, before we can generate the equation. So by reading the problem, so a force of 750 pounds compresses a spring 3 inches from its natural length of 15 inches. So find the work done in compressing the spring of an additional 3 inches. So we're going to find the work done in compressing the spring of an additional 3 inches. So this is where the variable force comes in. But so you are just going to determine the work done by compressing the spring of an additional 3 inches. Alright, so for the first sentence, so a force of 750 pounds, and then it compresses 3 inches. So with these data, so you can solve for the spring constant, which is K. So as seen in the figure on the right side, so you may follow this drawing. So you may make your compression as 0. So the natural length is from 0 to 15. And then compressing 3 inches, so this becomes 0 to 3. Then additional of 3 inches more, so that will be 0 to x. Because again, this particular figure will is already true for any distance of x, because you already have the spring constant. So solving for the spring constant, so formula is F equals K times D. Or in other books, so the formula is K times X. This is the formula here. So given the force of 750 pounds and a distance of 3 inches, so the spring constant is equal to 250. So by formula, the function of your force with respect to x is 250x. So this one. So you may be confused with the terms here, but your delta x will just translate to dx when you apply it in the formula. So to make the long story short, so if you try to use the formula f of x times dx, so once you determine f of x, so you can directly plug it in the equation, and what is left for you to do is just look for the limits of integration. So since we are just compressing from we are compressing of an additional 3 inches, so that will be from 3 to 6. So 3 to 6. So you won't be integrating from 0 to 6 because you're only asked to work to look for the work of an additional 3 inches. So to sum the steps, so you have to look for the f of x, and then you have to look for the limits of integration to look for the answer. And also, if possible, so create your diagrams as much as possible. So kana siya is ako lang siyang gi-complete ang mga terms. So probably you'll be confused on how I explain these things, but you can just sum it into 3 steps. So create your diagrams, and then next is look for the function of x, and then lastly is look for the limits of integration. So I'm pretty confident that there will be a spring problem in the exam. Okay, marag mo na siyang magawas every time in the final exam. So if not, so it will be the lifting problem. All right, so do you have questions so far? All right, so no questions, so we can proceed. So next is lifting a chain. Okay, so lifting a 20-foot chain weighing 5 pounds per foot is lying coiled on the ground. How much work is required to raise one end of the chain to a height of 20 feet so that it is fully extended as shown in the figure? So other problems will already give you the diagram. So that's why in the steps I presented earlier, so create your diagrams if possible, because again, there are problems wherein the figure is already given. So if these are given, so you need to figure out the diagrams on your own, right? So again, since the diagram is already here, so we're going to look for the function of x. So you may be confused on how I try to establish my equations here. But to make this one in a simple manner, so coming from the 20-foot chain, weighing 5 pounds per foot. So 5 pounds per foot is already my force, because this is 5 pounds, the weight, and then times the distance per foot. So I can just make it as x, or in this term, since we are lifting, so this will be y di. So 5 pounds per foot. So I'm going to multiply this one with an unknown distance y, so that I can get the force, diba? So to eliminate the foot, or if you want to see it in a clear perspective, so 5 pounds per foot. So this term here is not yet a force, because you need to multiply this one with a distance for it to become a force, diba? So that's why we need to multiply it with 5 first. I mean with y first, y unknown variable. Okay, we don't know how much we'll be extending, diba? Of course, it is also presented that you need to um, raise it fully extended 20 feet. So meaning mahurot dito ang distance, di ba? So with this becomes our function of the force. So again, this is function of y because we are lifting vertically. So this becomes our function of y. So our limits of integration is from 0 to 20. So it should be fully extended. So 20 feet, so that it is fully extended. So our A is 0, our B is 20. Okay, if you want to follow this one, so pwede ra sad siya, but sa ako ang kuan is dapat siya masayon sa kuan. So 0 to 20, and then this will be 5y dy. So you can use your calculator and get the answer of 1000 foot-pounds or pound-foot. All right, so again, we did not multiply the weight with the 20 foot distance, because di na siya constant force, because again we are lifting, and we try to imagine that as we go higher, so we are exerting a lot more force, or compared with pushing problems, diba? So pushing problems, the gravity is constant, but for lifting problems, so there's an extra effort due to the gravity. So if you're going to ask me where the gravity term is applied, so it is applied in the 5 pound per foot. So even though it's not directly shown in the problem, so it is already implied in one of the given items in the problem. So marag mo na siya ang mga difficulty in problem solving. So in the presented problems will depend on the author of the problem. So if mo na yung style sa pag-generate sa problem, so can't do much about it because it is his or her style. So muna, we need to dissect or decipher the different data that is coming from the given words or phrases in the problem. So just try to um, review this one later. So I'm going to give you also link before we dismiss for work and liquid pressure for your extra notes, since this is a bit difficult to I think it's not difficult to understand, but you need a lot of effort for these topics for you to absorb sa kaning kuan, work and liquid pressure. All right. So questions for lifting problems. Okay, so there's no question. So another tip the for your problem is to look for the parameter which is the increment of force. So that will be your function of f of x or f of y. So in this problem, so you have a spherical tank of a radius. So this is radius. So mark wrong spelling. 8 feet is half full of oil that weighs 50 pounds per cubic foot. So find the work required to pump oil out through a hole in the top of the tank. So we need to determine the work done by pumping out the oil at the top of the spherical tank. Okay, so again, since the diagram is already given, so there's no need for you to generate the figure. But if the diagram is not yet given, so this will be a huge problem in this particular um, example, because once you draw your spherical tank, so I think the spherical tank is not a problem in creating it, but what you will be determining later on is you need to create the x and y coordinate, because you'll be needing to generate the equation of the circle for you to be able to solve this problem. Okay, so the oil is 50 pounds per cubic foot. So this will be the force increment, or this is your candidate for your f of x or f of y, since we are pumping out vertically. So this is candidate for your, basta makita mo ka ng weight ka ng pounds per distance, yung ani na mga terms, so those are your function of f of x or f of y sa problem. Okay, so for this problem, we cannot just totally use this one that pwede siya makuha dito into 50 times y, di ba? Because the oil is in a semi-spherical shape, di ba? Dili siya pareha ganina nga. The chain is in the vertical condition. So that's why you can just multiply it directly with the distance y. But in this case, our per term here for our force increment is cubic foot. So meaning our aspect here is in volume for us to create the function of the force with respect to y. The force with the function with respect to y. So ganina is I think it's 20 pound per foot. So meaning our term here is in linear. So that's why we can directly multiply it with y distance. But for this problem is we need to multiply it with a certain volume. And this is where we can use our differential strip or differential disk. So for differential disk, so since we can generate the volume for differential disk, so the distance y is your dy, and the circle is pi r squared or pi x squared. So that's why the term here is, you can also create this one as 50 pi x squared dy. Now this is where the problem is getting more confusing, because if you don't have any analytic geometry in your first year, I mean in your senior high, so muna siyang lisod. So if you don't know how to generate the equation of the circle, if you don't know how to generate the graph for circles, so kana medyo lisod yun siya i-absorb. So this is the purpose of the x and y coordinates, because the x and y coordinates will give you the formula for the circle. So the circle is coming from the top portion of your differential disk. So by analytic geometry, so the formula for the circle is x minus h squared plus y minus k squared. So if you have this one in your senior high, so it's much better. But if you don't have this one, this is the formula for the equation of the circle. So h and k being the center of the circle. So let's say this portion here is 8. So that's why the y distance is y minus 8, and then the x portion is at the center, so that's why the h is 0. So you have an equation of x squared plus y minus 8 squared equals 8 squared. So since we need to make our terms all in the function of y because of this term here, so isolating x squared to replace it in the formula earlier, so this gives us the equation of this one. So ako lang siyang introduce because base na mo gawas, diba? Pero nag-feel ako wala kay, given that the EM coordinator is Sir Tamar, so Sir Tamar is only giving you easy problems. So if si Sir Fornis pa to, katong chairman sa CE, so basin na yung mga inaani na magawas. Right, so this can also be displayed as 50 16y minus y squared dy. So you can now integrate this one. So medyo libog-libog siya, but ano siya ang kuan sa work if it's variable force. So medyo daghan kayo mga possible topics na inyong ma-approach for work. Yan mo lang ito if you don't have any analytic geometry in your senior high or in your high school, So kana medyo lisod siya i-absorb. Sabi na katong kaninga problem, kaning example number 3. So the terms will be difficult to trace. Maglibog mo og asa ni siya gikan if you don't know what this where the terms are coming from. So sure ko wa may questions ani because again it's a difficult problem and I understand that kuan siya medyo difficult siya i-absorb. Okay, so this is the problem set. So there are 4 problems. So for the second problem, you may refer to the first example. For the third problem, you may refer to the second example. And then this one is you may refer to the third example for your draining out problem. So this one is in the first problem, since you're already given the function of x, so diretso na siya katong formula, di ba? So from 3 to 7, now diretso na siya. X squared minus cosine 3x plus 2 dx. Bakay, function of x naman siya daan. Gitagaan mo daan sa equation. Then gitagaan mo daan sa limits. So this na formula. So nga na maglabad-labad pa man, di ba? Given na tanan. Okay? So these are the problems that you need to solve. So this is not a problem set that I'm going to that I will ask for your submission, but this is for your review lang. So I think the third problem is a bit difficult since you will be getting the formula for the equilateral triangle. So medyo muna siyang lisod. So again, if you don't know how to get the equations, your equilateral triangle, so kana medyo labad jud siya. Alright, so let's proceed now to the fluid pressure and fluid force. So I'm going to try to discuss this one as easy as possible. So pressure is defined as the force per unit area over a surface body. So the pressure may be an object at a depth of h in a liquid, and the pressure can be solved by multiplying the weight density of the liquid, which is W, times the depth of the object where it is situated in the liquid. So in fluid mechanics, the pressure is equal to gamma times H. That is the formula. So this formula here is coming from a reference or a book, so that's why it's WH. But in fluid mechanics, this is gamma times H. So gamma may be any liquid. It may be water, it may be oil, it may be mercury. So ano siya inyong kuhan. But in most cases for these problems that we're going to solve, especially in the exam, so what you will be dealing in the problem mostly is the unit weight of water. So unit weight of water have a constant figures. So in English system, that will be 62.4 pound per cubic foot. In metric system, that will be 9.81 kilonewton per cubic meter, or 9,810 newton per cubic meter, or you can also have it as 1,000 kilogram per cubic meter, or 1,000 grams per cubic centimeter. So that's the different values of the unit weight of water. So again, it's not limited only to water, but I am only presenting this to you because most of the problems okay, puro siya water. So later on when you go to your third years, so you'll be introduced with different values of the unit weight. So for example, unit weight of mercury, that will be 13.6, so on and so forth. So daghan na siya mga different values for the different liquids. So seawater, fresh water, and daghan na siya dito sa fluid mechanics. So to determine the force, so notice that if we try to observe the unit weight is force per volume, diba? Pound per cubic foot, kilonewton force per cubic meter volume, newton is a force per cubic meter, that will be volume. So the remaining two is for scenarios wherein the given problem is only in weight or in mass. That's why it's kilograms and grams. So kaning first three is the unit weight. So if it's force, that is unit weight. If it's mass per volume, that is called density. Ana. In English term, it's called weight density. That's why kuan siya. In metric terms, it's called unit weight and then density. Sa English, kay since ang English isa ra man kabuk ang sa English system, that's why it's called weight density. So of course, if we want to try to determine the force with respect to the density given, or the unit weight given, so we need to eliminate this one by multiplying it with a certain volume, di ba? For us to determine the force. So that's why if you try to look at the formula, the unit weight or the weight density is multiplied by the volume, H, L, and dy. Then C to D is the displacement in the vertical direction. So if you try to determine it in an easy fashion, so the force is equal to the unit weight, or let's say gamma, times the integral of the derivative of the volume. So muna siya ang easier perspective of the formula. So you need to determine the depth of the water, so H, then the length, so the length and the dy, length and dy, this term here is coming from the horizontal strip of the submerged plane or of the submerged body. Horizontal strip of the object or of the body submerged at a certain depth. So let's try to figure out the formula with a problem para inyong ma-appreciate. So again, I already give everything in this example. So it's up to you to determine the different portions or decipher the different parts of the solution. So in most problems for fluid force, so you'll be determining the force exerted on the different submerged objects. So for example, this object here, it's a trapezoid. So again, the problem here will be about the analytic geometry concept. So you need to, so after determining or after drawing your trapezoid, so you'll be establishing your x and y plane in the diagram. So in this concept, so my suggestion is always make your x and y origin at the surface of the water. So the x-axis is the surface of the water, and then the y-axis is splitting the polygon in its symmetrical axis. So meaning it is dividing it into two different equal portions. Okay, so the depth of your HY is going to the horizontal strip. Going to the horizontal strip. So it's negative y because coming from the x-axis, that's 0. So going towards the vertical strip, that is negative y distance. That's why your depth is equal to negative y. Now again, as per formula, force is equal to W from C to D, HY, L of y, dy. So again, L of y times dy is the horizontal strip. So for example, this is the horizontal strip. So the length of your horizontal strip is this particular distance. And then your differential, the width of your differential strip is dy, diba? Or delta y. So this is dy. This is L of y. So there's a purpose why we place the y-axis in the center of your polygon. So the purpose of which is coming from this distance here, x left. So x left will become 0, diba? And then going to the right side, that will be your x right. So meaning your length of your your horizontal strip will be twice this distance, diba? Which is x right minus x left. And then take note that x left is 0 because that is the y-axis. So how can you determine your x right? So that's another problem in analytic geometry. So if you have 2 points, so you need to find the equation of the line. So if you don't know how to find the equation of the line, so kana medyo lisod siya. So there are many ways to determine the equation of the line. So if you have 2 points, so you can use the 2-point form as shown in the figure. So that will be y minus y1 over x minus x1, y2 minus y1, x2 minus x1. So that is the 2-point form of the equation of the line. So with everything that has been done in the calculation, so you need to isolate x, and this becomes your x right. So again, x left is the y-axis because that is x equals 0. So determining further, so this is your length, and then plugging everything in the equation. This is the answer for the fluid force. For the limits of integration, it is only from -9 to -4 because that is where the trapezoidal gate is situated. So if you go back to the figure, so this is -4, this is -9. So the force is only covering where the vertical gate is, or the trapezoidal gate is in the y aspect. So it is not from the surface of the water, but only where the fluid is, where the object is situated. So that is from -9 to -4. So to make the long story short, so diagram first. Then next, identify the hy, the depth. So most likely it is just negative y. So itong i-properly ugan be. So next step is x and y axis. Establish x and y axis. So x-axis at the surface of the water, surface of liquid. Y-axis is at the center of polygon. So again, this is important later on because you will need to determine the length of the horizontal strip. So first is to identify the depth. So most likely it is the negative y aspect because the you are going downwards. The next is you need to determine the length of the strip. So that is x right minus x left. So most likely what you'll be needing right after this one is just the x right, because x left is already x equals 0 because you placed your y-axis at the center of the polygon. So length of your horizontal strip will be equal to 2 times x right. Then lastly is use the formula. So to sum the steps in this fluid pressure. All right. So questions? Questions or libog na no? Libog. Kapoy na sir. Kapoy kay tapos na sa SEM. So muna, wala ko naghatag og problem set kay para sige na mugtuon for the exam. Alright, so I think there's no question. So let's try to proceed with the next. Alright, so in this problem, so notice that the x component, the x axis is not on the surface of the water. So of course, you may also still place your x-axis in this portion here. So ngano iya mangi-place diri sa kuan where the circle where the circular portion is. So there's a purpose to it because again, once you establish the equation of the circle, so again, the equation of the circle is x minus h squared plus y minus k squared is equal to r squared. So if I try to place this one at the top, so notice that my origin of my circle is mo displace pa siya og negative 8 in the y-axis. So meaning mahimo siyang x minus 8, I mean x minus 0 because the origin is at a 0 now. There's no x displacement. Then my y is y minus negative 8 squared is equal to 1 squared. So meaning my equation is x squared plus y plus 8 squared is equal to 1. So you can see a difference here because the origin is at 0, 0. So automatically it becomes x squared plus y squared equals 1 squared. Diba? So muna siya ang difference if I try to place the x-axis at the surface of the water. So again, same problem. So diagram first. The next is you establish the x and y axis. So in this case, the problem is situating the x-axis at the center of the circle rather than at the surface of the water. So of course, the problem will still give you the same result if you put the x-axis at the top of the surface of the water. But muvary lang ang inyong depth, diba? So for example, this one is your x-axis. So instead of 8 minus y being the depth of the horizontal strip, so this becomes negative y lang, diba? For the depth of the water. And then for your x right, so this is your x right minus x left. So x right is the equation of the circle. So since you are situating your x-axis at the top of the surface of the water, so this becomes x. So x equals 1 minus y plus 8 squared and then square root. So this becomes our x right if our x-axis is at the top of the surface of the water. So diri sa iya, since the x-axis is at the center of the circle, so muna siya iyahang x right. Alright, so mura na siya. That's pretty much about this topic. And then this is the force. So for the problem set, this is the problem set for your liquid pressure. So you may, so I'm going to give you an idea on where to put your x and y plane. So dire, x and y plane. So surface of the water, this portion here. So let's say this is your horizontal strip. Horizontal strip. So determining your x right, you need the equation of the line here. So pwede po din extend dire to get the equation of the line. Dire is you need to determine the equation of the line also. Also on this portion here, equation of the line. So again, don't forget that your length is twice x right. Alright, so that will be your review problems for liquid pressure, and for the answers for your work and liquid pressure problem sets, so these are the answers for you to review if you got the correct answer. Alright, so questions or clarifications? Okay, so mo na may tubag. So basin mo na questions.